Trends. Today we start. Our next topic is Heisenberg uncertainty principle. Okay. This principle name is uncertainty of principle. Okay. Then it is given by Werner Heisenberg in 1927. According to this law, we clear about the speed and position of electron. More experiment done by Werner Heisenberg, and its conclusion is it's impossible to determine simultaneously the exact position and exact movement of electron. That is Eisenberg uncertainty principle. Okay, so its principle is it is impossible to determine simultaneously the exact position and exact momentum of an electrons. Okay, it is the law of or principle of Eisenberg uncertainty principle. It is impossible to determine simultaneously the exact position and exact movement of an electron in particular atoms. Okay, then if we consider uncertainty position by del x and movement by del px, so it's less than 2 for pi upon 4 pi, sorry, h upon 4 pi. Clear? Then we know about the value of px. Del px is equal to del mv, where m is the mass of electrons, v is the velocity of electrons. So we put here del x dot del m ev less than 2 h upon 4 pi, where h is a Planck constant. Okay, so now del x we multiply inside, del v is then h upon 4 pi, then we transfer m here. Okay, we mention here m, only m, not me. Okay, so it is the formula or mathematically expression of Heisenberg uncertainty principle. Okay, the Heisenberg uncertainty principle is it is impossible to determine simultaneously the exact position and exact movement of an element, where del x is uncertainty in position of particle. It means for electron, p del px is equal to uncertainty in momentum of particle. Clear? If the position of the electron is known with high degree of accuracy, then the velocity of the electron will be uncertainty. Okay, if we know about the position of electron with high accuracy, so the movement or speed of electron we does not know. Okay, so if we know del x, so uncertainty of del p, then if we know del p, so the position is uncertainty. Clear? We don't determine both with each other. Okay, so next topic is quantum numbers. It's very important for you. Okay, quantum numbers. Some numbers used for the determination of location of electron in an atom are called quantum numbers. Okay, some numbers used for determination of electron are called quantum numbers. It's very important topic. Quantum numbers, because you again studying your physics quantum. Okay, there are 4 quantum numbers which tell the most likely location of an electron in a specific space around the nucleus. Okay, what is meaning of quantum numbers? There are 4 quantum numbers which tell the most likely location of an electron in a particular specific space around the nucleus, because we know electron present around the nucleus, clear, in orbit. Again, we have 4 types of quantum numbers. Types of quantum number. Okay, 4 types. First is principal quantum number. It's denoted by n. Then second is azimuthal quantum number. It's also called angular quantum numbers. Okay, maximum times we use angular quantum numbers, azimuthal quantum numbers or angular quantum number. Then third is magnetic quantum number. It is denoted by ml because the number of magnetic quantum number depend on azimuthal quantum number. Then fourth is spin quantum number. Spin quantum number is denoted by ms, but we use only s for the spin quantum numbers. Okay, what is meaning of quantum number? There are 4 quantum numbers which tell the most likely location of an electron in a specific space around the nucleus. Okay, so already I say about the quantum numbers. We use some numbers for determination of location or position of an electron in a atoms are called quantum numbers. We have 4 types of quantum numbers. First is principal quantum number, it denoted by n. Second is azimuthal quantum number or angular quantum number, is denoted by L. Then third is magnetic quantum number, it denoted by ml because it depend on L. Then fourth is spin quantum numbers, it denoted by ms. In our NCERT books, sometimes we use only s for the spin quantum numbers. Okay, the 4 quantum numbers show different position of electrons. Like that, principal quantum numbers, it denoted the energy level. It's denoted energy level. It means n value always equal to the number of orbits. Okay, number of orbit. It means n value is equal to k l. I mentioned here n is equal to k l m n o p q. It means 1 2 3 4 5 6 7. Always the principal quantum number present in integer value. It starts from 1 to infinity, but we have only 7 orbits now in this time. Then second, azimuthal quantum numbers. Okay, our second quantum number is azimuthal quantum number. It's denoted by L and it's show sub levels or sub level energy levels, then sub level, and its value are different for different orbitals, like that here. S is equal to 0, P is equal to 1, D is equal to 2, and F is equal to 3. Okay. Then next I remove here, then write variable. Okay. Here azimuthal quantum number is denoted by L and it's used for sub-levels. Sub-level, it means in a orbit we have 4 different types of blocks: S block, P block, D block, and F block. Clear? So the L value for S orbital is 0, L value for P orbital is 1, L value for D orbital is 2, and L value for F orbital is 3. Clear? Then our next is magnetic quantum numbers. Magnetic quantum number. Clear? It's denoted by ML. These quantum numbers depend on azimuthal or angular quantum numbers, because the value of magnetic quantum number is equal to the minus L to plus L values. What do we mean by minus L to plus L? Okay. Then magnetic quantum numbers show particular orbitals. It show particular orbitals. We already know about the S block have only 1 orbitals. Then P block have 3 orbitals. D block have 5 orbitals. 1, 2, 3, 4, 5. Then F orbitals have 7 orbitals. Clear? So every orbitals have different numbers. Like that here, minus L to plus L. We have L value for S orbital only 0. So minus 0 to plus 0, it means only 0, because we use 0 without any sign. And again P. So the P value for L is 1. So it's used minus 1, 0, plus 1. So the magnetic quantum numbers for P orbital, P blocks, we have 3 different numbers: minus 1, 0, plus 1. So this orbital is number is minus 1, this 0, this plus 1. Then next, for D orbitals, we know the L value for D orbital is 2. So the number is minus 2, minus 1, 0, plus 1, plus 2. That's all. Okay. So we have 5 values, because in D block we have 5 orbitals. 1, minus 2, minus 1, 0, plus 1, plus 2. Okay. Like that here for F orbitals, we know the value of L for F orbital is 3. So minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. There are magnetic quantum numbers. Okay, it depends on minus L to plus L. Okay, done. S value for magnetic quantum number is 0. P minus 1, 0, plus 1. D minus 2, minus 1, 0, plus 1, plus 2. Okay, then F minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. Clear? Now we have one more quantum number, is called spin quantum number. Okay, I remove the definition of quantum numbers. Okay, so spin quantum numbers, fourth. Spin quantum number. Okay, every orbitals, okay, every orbitals have maximum 2 electrons. Okay, so spin quantum number show spin of electrons. Spin of electrons. Clear? So we use 2 terms for the particular electrons. If we calculate quantum numbers for these electrons, so spin quantum numbers value is plus half. Okay, if we calculate for these electrons, so the value of spin quantum number is minus half. Clear? So there are 4 quantum numbers. First is principal quantum number, second is azimuthal quantum numbers denoted by L, magnetic quantum number denoted by ML, and spin quantum numbers denoted by small s or ms. Both are symbol with for spin quantum numbers. So value of principal quantum number n is equal to always integer values, non-zero values 1, 2, 3, 4, 5, 6, 7. Then the azimuthal quantum number n is show sub-levels of orbits. So we have 4 blocks S, P, D, F. So the value of L for S orbital is 0. The value of P is 1. Value of D is 2. Value of F is 3 for particular azimuthal quantum numbers. Then magnetic quantum number ML is equal to minus L2 plus L. Clear? So for S is 0, P minus 1, 0 plus 1. Okay. Then D minus 2, minus 1, 0 plus 1 and plus 2. Okay. Then F minus 3, minus 2, minus 1, 0 plus 1 plus 2 plus 3. Clear? S orbitals have only one magnetic numbers. Then P orbitals have 3 numbers. D 5 orbitals and 5 magnetic numbers. And F have 7 orbitals, have 7 magnetic numbers. Okay. Now we use all quantum numbers to determination of electron position. Okay. I remove first. I think you understand very well about the quantum numbers. Now we use it. Suppose we have one question. Calculate quantum numbers let quantum number for last electron of sodium atom. Clear? But we have one question here. Calculate the quantum number for last electron of sodium atom. So we already know about the electronic configuration of sodium. 11 is 1s2, 2s2, 2p6, then 3s1. So last electron entering 3s1 orbitals. Okay. Before calculations of quantum numbers, we clear about these orbitals meaning. So we have here 3s1. We already know about the orbital structure. In 3s we have only one box, one orbital, and only it have one electron. So the principal quantum numbers show by here it's n is equal to 3. So first quantum number is n is equal to 3. Then the second azimuthal quantum number or angular quantum number show by these orbitals is called L. So we already know about the L value for s orbital is 0. So the L is equal to 0. Clear? Then spin quantum number, magnetic quantum numbers. We all know calculation with minus L2 plus L. So for S only magnetic quantum number is 0. Okay, ml. Then ms spin quantum number, it depends on this. We already mentioned here, if our electron is clockwise, so its value is plus half. So these 4 numbers are called quantum numbers. Every quantum numbers are different for particular electrons. Clear? Every different electrons have different types of quantum numbers. We have some more Pauli principles like that, then we'll discuss in later. But first we consider how to calculate the quantum numbers of particular orbitals. Now if I want to calculate quantum number for last electron of magnesium. Okay, last electron of magnesium. So what is changing magnesium? First I remove it. Okay. Then magnesium Mg12. So 1s2, 2s2, 2p6, 3s2. So we know about electronic configurations, orbital electronic configurations here. Clear? So 1 first electron, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, then 12. This is our last electron of magnesium. Clear? So the n value is equal to how much? Okay, right, 3. Then L value is for S 0, M also 0, for L is equal to 0. So Ms is equal to minus half. Okay, you have clear here. We have 3 quantum numbers are same, but 4th quantum numbers are different. This is a Pauli exclusion principle. Okay, 2 electrons for particular atoms does not have same quantum numbers, 4 set of quantum numbers. Okay, we take one more example. Okay, now I want to calculate 2p1. Okay, so 2p1, we have orbitals here, 3 orbitals, 1 electron are there. So n is equal to 2, L is equal to P. So we know that L value for S is equal to 0, P is equal to 1. So here 1, then Ms, so minus 1, 0, plus 1. So our electron present in minus 1, so we put here minus 1. Then S, so clockwise, so plus half. Then if we have suppose last calculation for last electron like that 3d6. Okay, we want the calculation of quantum numbers for last electron. So 1, 2, 3, 4, 5, 6. So last electron enters here. So quantum number for that electrons, n is equal to 3, L is equal to 4. So P, D is equal to 2. So L value for D is 2. Then M, so minus 2, minus 1, plus, 0, plus 1, plus 2. So minus 2. Then S for anti-clockwise is minus half. Okay. So I think you understand very well how to calculate the quantum numbers. Okay. So please solve some numericals problem from our NCERT exercise based on quantum numbers. Thank you. Jai Hind, Jai Bharat.